All right, as I've already said, welcome to Ceph Day CERN. I'm really happy to be able to talk, give a bit of an introduction to Ceph, as well as the community, and a brief about what's going on inside of Nautilus. So, a little bit about myself. I am Mike Perez, the community manager for Red Hat, and I work part of the open source program office. We assist people at Red Hat as well as other open source projects in trying to bootstrap them, whether it's bringing up the community, putting on events like this, as well as helping with other things like governance and code of conducts. So, I would also like to thank our sponsors, SoftIron, as well as Western Digital. Without them, we wouldn't have this event, and you wouldn't have food to keep you going for this event as well. So thanks to them as well. And also thanks to CERN for providing us this beautiful venue. All right, so 8 months ago we established, or maybe now it's been a little bit over 8 months now, but for Ceph Day Berlin, we announced the Ceph Foundation. We originally started with 31 members, part of the organization, people dedicated to support the goal of Ceph and the mission statement that goes with it. We launched with 13 premier members, 10 general members, 8 nonprofits and government organizations that are working towards the Ceph goals. And we also added in 2 new general members as well as 2 new associate members as well, just this year. Also, I would like to thank the Linux Foundation as well. They help us with the Ceph Foundation and bootstrapping everything for the bigger events as with CEPHFS, as well as helping us with everything from contracts and whatnot and the logistics there. So thanks to them. If you like what you see here for the Ceph Days, we have a bit coming up, and they're coming all over the place. If you want to put on one, if you're interested in what Dan has had to already go through, please reach out to me, reach out to Sage, email us if you're shy. I would love to hear from you and help support you in putting on a Ceph Day in your region. All right. So the first thing I want to talk about that I think is pretty important inside the Ceph community is improving our documentation. We have meetings that we do inside of the Ceph community. There are meetings around performance and testing. It could be everything from our new work inside of the Blue Store performance changes, as well as, let's see, the orchestrate, any of the work that's happening around orchestration inside of Ceph as well. But we have this one meeting in particular called DOCUBETTER, and it's going along right now. We're looking to make improvements inside with the tooling that we do with documentation, as well as how do we better improve onboarding and getting information to people. So if you want to be part of this initiative, we welcome you. Anybody could be a contributor to this. The meetings happen every second Wednesday, and then the 4th Wednesday of every month. So. Along with that as well, the Ceph Foundation has approved the board members for us to have a documenter that we want to have as a contracting role. And so this person would be dedicated to improving the documentation, working with the Ceph community, and be funded by the Ceph Foundation in order to make these improvements. If you are interested, we are accepting resumes right now. They already came in, and we're already going through them. So please reach out as soon as possible. We'd love to hear from you. All right, so let's talk about what is Ceph. Just a show of hands, who is completely new to Ceph? Hey, guess what? I'm running low on time, so we can kind of go through this pretty fast. So, so as you know, Ceph has a variety of different interfaces that interact with the radio storage itself. This provides everything from S3 interfaces, S3 and Swift compatible interfaces, so that you can do your HTTP puts, your gets to interact with your data. You can interact with data with block storage, as well as through a POSIT compliant file system. And it looks something like this. Typical graph of it. And as we know, one of the struggles inside of storage itself is exactly knowing where the data actually lives. For usual approaches, people like to do things like have metadata servers. And then you end up having to maintain those, a cluster of those. You end up having to also maintain the capacity comes with the metadata servers as well. And you have the additional network hop. And of course, we do a different approach to that. We believe in doing a very quick hash algorithm calculation of where exactly the placement of the data is actually located using an algorithm called Crush. Giving the actual object to the Crush algorithm and knowing the cluster state that comes from the monitors themselves, we are able to do a quick calculation of where exactly the data is residing. This could happen for everything for read and writes, of course. And as we know, we also have placement groups. The placement groups are giving us failure domains. It's pseudo-random, and it's doing all the calculations, again, straight off of the Ceph client itself. And then from there, there are no lookups. It's a stable mapping. You might be used to some approaches, such as like with hash rings, where you have 3 servers, and you add a server, and everything gets moved over to that server. Ceph has a different approach to that. Let's say, for example, you have 10 servers, and you add another server. 1/11 of your data is actually going to get moved around, as opposed to the hash ring approaches. So inside of Rados as well, we have, you could have namespaces of pools. These pools, of course, can have a variety of different configurations. You can have things like the solid state drives for one pool. You can have spinning disks for another one. You can even have the data being placed in a completely separate room if you wanted to. Whatever your use case is, just like with the interfaces, Ceph is a flexible solution to this regard. So the 2 main processes, of course, are the OSDs and the monitors. The OSDs map right to one disk, and there's a lot of them. It does all the I/O, the read and writes. It knows when its fellow peers are down as well. It can report that over to the monitor to make a decision on whether or not it has to place that data at another location to meet the requirements of the replication factor. So with monitors, again, they agree on the state of the cluster. Say you have 1,000 OSDs. One goes down, the monitor gets a report, marks it down, clients talk to the other OSDs, and then from there, if the OSD is down for too long, the monitors create a new map, and the OSD is replicating that objects, or the various objects that that previous peer was serving. And it's also important to note that the monitors themselves are not part of the data path whatsoever. So the key terms that we use to describe Ceph is a unified storage system, as well as a storage platform. Some people call it a SDS, which was used for a popular term years ago, and as well as a branding exercise that we've tried to do, as well as some people call us the Linux of storage. That's quite flattering. But instead, we like to think about why is Ceph? Why does it exist? What motivates the engineers, the community that comes to working on it? So Ceph is free. It's open source software. It's free to use. All the features are available to any organization. You can take advantage. There is no separate code that isn't being put out that where some features are not available. Everything is available. Everybody can figure out how it works, what it's doing. They can fix bugs, they can make improvements, and then they can share those improvements with everybody else. Open source. So it's also reliable. It's a durable storage service. It has no single point of failure. It can replicate. It has erasure coding. We also favor consistency over performance. Typically, with other distributed file systems or any other distributed solution, performance is usually looked at as a priority, but we actually think differently. We want your data to be safe. We favor consistency over performance, and so we're always going to take the path of making sure that your data is safe. Ceph is built to be scalable, and it provides an elastic infrastructure. You can grow and shrink it as your requirements change. You can add or remove hardware while the cluster is online and being used. You can do rolling upgrades as well, and Ceph will go ahead and handle those different various versions as your data is being written and read. You could scale up to bigger, faster storage. You could scale out to within a single cluster to a site. And the features allow you also to have a federated multiple clusters together to replicate cross clusters to meet your requirements as well. And also for those multi-data data center footprint requirements. So for the Ceph releases, though, we do these about every 9 months, and we backport 2 releases at a time. We upgrade 2 releases at a time, and Nautilus came out in March, and we're working on Octopus now. Sage is going to be speaking more on that. So, and a little quick numbers here about the Ceph community. We have 61 organizations and 276 contributors, 9,773 commits that have came out of just in the Nautilus release alone. So I'm going to briefly talk about Nautilus. I don't have too much time to go over everything, but the first priority was ease of use and management. We wanted to focus specifically on getting rid of this reputation that Ceph has gained in earlier days of being complicated and hard to use system. It's kind of our own fault because when we first worked on this, we were, a bunch of system administrators wanting to have something that's scalable and flexible and fast. And of course, Sage is going to touch on this more, but our priorities have quite changed. We neglected ease of use, and the last 3 years, the work has gone to change that. So the biggest thing I want to focus on is the dashboard. The dashboard is worked on by the component lead Lens. It is awesome. Out of all the dashboards that we've been working on, we finally have a community that is focusing on one particular dashboard that is actually integrated within Ceph itself. And there is a couple key things that came out of the dashboard space. Again, we had convergence on a single implementation. There's several dashboard projects that existed outside of Ceph. Our efforts were fragmented and across different vendors and communities. Everyone is now collaborating on this one implementation now, and it's part, again, of the core Ceph. So every time you install Ceph, the dashboard is there. You just turn it on. It provides everything from the metrics and the monitoring to basic management functions to create pools, as well as managing the devices. And we're now trying to take that last step in managing the hardware so that you can manage deployments, expand the clusters within the dashboard, as well as replace disks within this graphical user interface. And the second exciting piece that came out in Nautilus is the Orchestrator API, or as we like to call it, the Orchestrator sandwich. So it's an abstract interface into the Ceph manager, Damien, that lets Ceph reach out to the various orchestration framework that we use to deploy Ceph itself. And this gives you a very abstract way of having implementations for things with other configuration management tools, such as ROOK for your Kubernetes cases inside of containers, as well as Ceph Ansible, as well as DeepC, which is based off of Salt, and of course the SSH orchestrator itself. To use this API to deploy the actual Ceph itself, it's compromising the Ceph system itself. So functions include fetching the node inventory, which nodes are participating in the cluster, creating and destroying OSDs or monitors that are deployed on the nodes. We could add blinking LEDs on your storage enclosures as well. And the goal is to build a unified command line or graphical user interface that is a consistent set of commands to list devices, add those different Daemians, replace disks, and again, regardless of what implementation of configuration management tool you're using, the interface will support those regardless. And so Nautilus has a partial implementation of this, but will be more focused inside of the Octopus release. And a good example of this that allows us to do this in Nautilus is the managing CEPHFS NFS gateways. So you have a set of NFS Ganesha Daemians that are running. There are NFS gateways that export the CEPHFS via NFS4. They run active-active in configuration. They're essentially stateless inside, and they store their configuration inside of Rados itself. Super easy to deploy. They make the cluster failover semantics correct, so NFS grace periods are handled correctly. And it's all fully managed through the orchestrator interface itself, as I talked about earlier. So you can use the command line interface, you can use the dashboard to create a CEPHFS subvolume, and then set up the NFS export that way. And of course, you can read more about this on the Ceph blog. So, another really exciting feature that came out for Nautilus is having the ability to, with this historically has been a bit of a black magic inside of Ceph of how many placement group numbers do you set. It was very confusing, limited amount of guidance that you would find on the internet. Your miles may vary. And majority of people in this room might not know what this is. And if you don't, that's great. Case in point. This is something you really shouldn't know about. So we have now the ability of several things. auto-managing the placement group numbers. So Ceph can actually look at the utilization of your system, how much is stored in pools, as well as the number of devices available, and choose a value based on that information. And you can also give it hints as well, as like how much data you're planning to use. Along with that, we have placement group number decreases. Historically, you could not decrease this number, and now you can. So if you made a mistake in previous versions, you can now adjust that. Sorry. And for people who've given feedback, Ceph is complicated. I think this is one of the biggest things to check off the list. So, along with that, we have new device health metrics capability. It looks at the different daemons that are consuming raw devices themselves. It specs the hardware and define what specific physical devices they are consuming. They identify devices by vendor model as well as the serial number, so you can know what devices are being used. And along with that, we have the ability to do failure prediction, that is automatically scraping the devices based off of SMART. There's a couple of options that exist. You could go with a local mode that will basically use a pre-trained model that's embedded into the Ceph cluster itself. And then there's also an option for various vendors to provide cloud mode as well to have a better model of for these predictions. So let's see, I'm going to skip along because don't got too much time. But one of the things I wanted to touch on was RBD top. This has added in a lot of instrumentation inside of Rados that allows us to sample the request stream, identify which clients are doing the most I/O, and a lot of this has surfaced so far just in the RBD case, of course, but more is to come in Octopus. We're, of course, looking at the Rados gateway as well as CEPHFS and Rados itself. All right, so Kubernetes. How many people are looking into Kubernetes in their clusters, deployment infrastructure? Yeah, okay, great. How many people know about Rook? Excellent. One of the things I forgot to mention, there's Rook swag and Ceph swag over by the registration table, so please pick those up, as well as a Ceph enamel pin. Bring some to your coworkers too. So inside of, we care about Kubernetes in a couple of ways. We want to make sure Ceph can provide storage inside of Kubernetes, of course. Any scale-out application infrastructure is also going to need scale-out storage. So we're interested in running Ceph clusters in Kubernetes. Kubernetes is increasingly being used inside of different infrastructure layers. And so Ceph being a complicated solution to deploy, this can help simplify the deployment and management. And so, of course, we do this with all of Rook. It's a robust operator for Ceph inside of Kubernetes. Rook makes it extremely easy to deploy Ceph. It fills two distinct roles. It intelligently manages the different Ceph daemons, as well as make intelligent decisions when adding or removing monitors to preserve the quorum. It's scheduling your stateless and daemons across different nodes, as well as all the tedious things that end up happening that with human intervention, there could be errors. So all of this, though, is declarative within the custom resource definitions that you might be used to inside of Kubernetes. And you use these CRDs in order to deploy the clusters, as well as create pools, create file systems, everything I was talking about earlier with the orchestrator sandwich. And the community is super enthusiastic. We're happy to work with them. I mentioned earlier about with Ceph Day that we're having that is not officially co-located with KubeCon US, but in November 17th, we're going to be having both a Rook and Ceph Day. So we're very excited to work with that community more. And for people who want to deploy Ceph in containers but without Kubernetes, we offer this through another means. The Ceph container projects exist to create an upstream standard container for projects to use. So both Rook and Ceph Ansible, for example, use this. You can, of course, use these containers in any sort of way that you want to without Kubernetes. And we plan to do this in other orchestrators in the Orchestrator API, such as SSH Orchestrator, which is the successor of Ceph Deploy. And the Rados Gateway has a new publish and new pub and sub capability. It's integrated in with the Knative serverless framework of Kubernetes. So when you're doing your gets puts, Rados Gateway can generate an event stream. And then from there, whatever those events are, you can kick off functions service functions to do some operation based on those events. All right. So, of course, we're also still working inside of the space of both with public and private clouds and hybrid clouds. A couple of new features that come out is the archive zone. It uses the Rados gateway multi-site replication to essentially archive every copy of every object overwritten. It does a cloud sync, which is a one-way replication between Rados gateway buckets to an external object store like S3. And we have a lot of ongoing cleaning up of working, refactoring, and planning around Rados to, in general, leading to the next version 3 to move forward to multi-site capabilities. This is not strictly multi-site, but it's but related. We have the S3 lifecycle policy API as well, setting automated tiering policy via standard S3 API, moving objects between different tiers of storage or even archival. Eventually, the tiered data will be able to be archived out to an external storage. And I think I am completely out of time now, but if you have any questions, I know I kind of briefly went over stuff pretty fast, but please find me. I'm friendly. And if you're shy, please reach out to me by email address or Twitter. So thank you. And so next, we will have Sage talking about what's new coming up in Octopus.